Welcome back to our channel. Today we're diving deep into one of the fundamental concepts in machine learning supervised learning. Whether you're a beginner or looking to brush up on your skills, this guide will walk you through everything you need to know, from the basics to real-world applications. Supervised learning is a type of machine learning where the model is trained on a labeled dataset. But what exactly does that mean? A labeled dataset is one that has both input and output parameters. The input features are the attributes or characteristics of the data, like age, salary, or house size, while the output labels are the desired outcomes, such as predicting house prices or determining whether an email is spam. So how does supervised learning actually work? The process starts with a labeled dataset, where each example in the dataset has an input and a known output. The model is trained on this data, learning the patterns that link inputs to outputs. Once the training process is complete, the model is tested on a separate set of data called the validation set. This helps us evaluate how well the model has learned and how accurately it can predict outcomes. Let's look at a practical example. Suppose we have a data set of different types of fruits, including apples, bananas, oranges, and grapes. The first step is to train the model to recognize each type of fruit. If the fruit is red, round, and has a crisp texture, it will be labeled as an apple. If the fruit is long and yellow, it will be labeled as a banana. If the fruit is orange and round, it will be labeled as an orange. If the fruit is small and round, it will be labeled as grapes. After training, we test our model using the test set, and the task of the model is to identify the fruit. The model, already trained on various types of fruits, will classify a new fruit based on its features and predict the output. Supervised learning can be divided into two main types of problems: regression and classification. Regression is used when we're predicting a continuous output, like temperature or market trends. For example, predicting tomorrow's temperature based on historical data is a regression problem. On the other hand, classification deals with categorical output, where the result is one of a limited set of classes, like identifying an email as spam or not spam, or determining whether a tumor is benign or malignant. Supervised learning encompasses a variety of algorithms, each suited for different tasks. Some of the most popular ones include linear regression, which is great for predicting continuous values; logistic regression, ideal for binary classification problems; decision trees, which work well for both regression and classification tasks; random forest, an ensemble method that improves prediction accuracy; and support vector machines, known for their effectiveness in high-dimensional spaces. Supervised learning is widely used in real-world applications. It powers systems that detect fraudulent transactions, filter spam emails, segment customers for targeted marketing, diagnose diseases, and even recognize speech. The possibilities are endless when you have the right data and algorithms. Supervised learning offers several advantages. First, it allows for accurate predictions based on past data. Second, because the data is labeled, you have a clear understanding of what the model is learning. This transparency makes it easier to fine-tune models for specific tasks. Finally, supervised learning is excellent for tasks where the relationships between input and output are well understood, such as fraud detection or medical diagnosis. However, supervised learning does have its downsides. It's not suitable for handling very complex tasks where the relationships between data are unclear or nonlinear. Additionally, the training process requires large amounts of labeled data, which can be time-consuming and expensive to obtain. Finally, if the test data differs significantly from the training data, the model's performance can degrade, leading to inaccurate predictions. In summary, supervised learning is a powerful technique in machine learning that relies on labeled data to train models for predicting outcomes. Whether you're working with continuous data in regression or categorical data in classification, understanding the right algorithms and approaches is key to success. Thanks for watching. If you found this comprehensive guide on supervised learning helpful, don't forget to give it a thumbs up, subscribe to our channel, and hit the notification bell so you never miss out on our latest content. Got questions or suggestions? Drop them in the comments below. See you next time as we continue to explore the fascinating world of machine learning